There are three types of problems when solving a quadratic. The first type is the ones you see here, where you have an x squared and no other pieces with x squared. The rest are just numbers. So we can solve for x squared with our regular algebra skills. X squared equals 25. Undo the square on the x by doing the square root on both sides, and you get x equals 5. This is the first time when you'll see something with a symbol that looks like a plus and minus. The reason we do that is because positive 5 squared equals 25 and negative 5 squared equals 25. So both answers are technically solutions. We say x equals positive or negative 5. On a graph, you would see a graph of x squared, which is a U-shaped parabola, and we're looking for when does that graph cross at 25. Both here at positive 5 and here at negative 5. Second problem, part B. First divide both sides by 3. X squared equals 36. And to get x alone, do the square root on both sides. X equals 6, but remember both positive or negative 6 squared could make 36. Same thing on a graph. You would see a graph of 3x squared, which is a little narrower. And when it is at reach up to 108 at positive 6 and negative 6 for x. On the other side is just one extra step before we finish solving. Subtract 15 on both sides. 5x squared equals 45. Divide both sides by 5. X squared equals 9. And then the square root on both. X equals positive or negative 3. Last one, if we subtract 75 on both sides, 5x squared equals negative 15. Divide both sides by 5. X squared, sorry about that, equals negative 3. And when we try to do the square root of a negative number, your calculator will tell you that there is no solution, because nothing squared could possibly equal a negative number. So we will write that there is no solution. This first method was regular solving with algebra if your equation has an x squared and no other x's shown. The second method has two separate x terms, the x squared and the linear x term. So what we'll do here is we'll take out the greatest common factor and solve by factoring. In the first problem, both terms have an x, so we'll take out that factor of x, and we are left with an x plus 4 to finish that distributing to get back to the original. Don't forget it equals 0. Now, when anything is multiplied together like this, 0 times any other number will equal 0. So this first piece, x could be a 0, because 0 times x plus 4 would still equal 0. On our second side, we're hoping that x plus 4 could somehow equal 0. So that 0 times any number could still equal 0. If we just simply solve for x, subtract 4 on both sides, and we end up with x equals negative 4. You could always check your answer by plugging them back into the original. Does 0 equal 0 squared plus 4 times 0? Yes, it does. And does 0 equal negative 4 squared plus 4 times negative 4? And it does. On a graph, this would look something like a graph with x squared plus 4x. It's going to look something like this. And it equals 0 here at 0 and here at negative 4. Second problem, part B, take out the greatest common factor between these two terms, which would be 2x. And we're left with x minus 2 equals 0. And then try to make each part of the multiplication be 0, so that 0 times anything else would still be 0. So 2x could be 0 to get 0 times something, or x minus 2 could be 0 to have a 0 times something. First problem, we can just divide by 2, and we get x equals 0. second problem, we can add 2 on both sides to get x equals 2. And again, you could check them by plugging them back in and seeing that when the x's are 0, it equals 0, and when the x's are 2, it equals 0. On our graph, we'd have a graph that crossed through the 0 line at 0 and at 2. Last problem. Here, the greatest common factor is only the letter x, so we'll take out an x. 3x plus 10 equals 0, and break it apart. X of 0 times anything equals 0, and something inside the parentheses of 0 times the x would make 0. Subtract 10 on both sides. 3x equals negative 10, and divide by 3, so x is negative 10 thirds. That one's a little bit trickier to graph, so I'll leave that one without a graph. This is solving by factoring because 2 terms both have an x in them. Our last method is called the quadratic formula. That is for when you have 3 different terms and none of them have a greatest common factor. What we will do, instead of factoring, and instead of trying to do a square root, is we're going to use this quadratic formula. And it's something you just have to memorize. The quadratic formula is negative b plus or minus square root b squared minus 4ac over 2a. The way we memorize it is by a song. And our song goes x equals negative b plus or minus square root of b squared minus 4ac all over 2a. When you're looking at a problem, the a is the number in front of the x squared, the b is the number in front of the x, and the c is the number that's alone. So we'll just replace those numbers into our formula. The formula says x equals negative b. Well, here the b is already a negative 7, so negative negative make it a positive 7 plus or minus square root b squared minus 4 times a. In front of the x squared is like an invisible 1. And the c is a 10 all over 2 times a. Now we just go to simplifying. X equals 7 plus or minus square root. If you need a calculator, you can use one. 7 squared is 49 minus 4 times 1 times 10 is 40. So you'd be left with a 9 inside that square root all over 2. Then you can find the square root. X equals 7 plus or minus, the square root of 9 is 3 all over 2. And here is where we break it apart to get our 2 different answers for a quadratic solution. We'll do one version where we do 7 plus 3 over 2, and a second version where we have 7 minus 3 over 2. So this first one, 10 over 2 is 5, and the second one, 4 over 2 is 2. On a graph, this equation would look something like this, where the graph crosses the 0 mark at 2 and at 5. Our last example is on the right. Notice with this problem, this is the first time with factoring or quadratic formula that we've encountered a problem that does not equal 0. So we will first change it to equal 0 by subtracting 2 on both sides. And 2 minus 2 would make 0. Now we can identify our a, b, and c number and fill in that quadratic formula. X equals, or again, the b was negative, so b plus or minus square root b squared minus 4. A is a 1, c all over 2a. If we simplify this, 4 squared is 16 plus 4 times 1 times 4. We end up with 32 all over 2. 32 does not have a perfect whole number square root. So what we'll do is we'll have to make a factor tree for that to reduce it. 32 is 16 times 2, which is 4 times 4. 2, 2, 2, and 2. So we've got a pair of 2's and another pair of 2's, which would make 4, and a leftover. So our original x equaled 4 plus or minus all over 2, but instead of the square root of 32, we'll put in our factor tree to answer of 4, the leftover square root of 2. The last step is to reduce this fraction. 4 divided by 2 would reduce to be 2, and here 4 divided by 2 would also reduce to be 2 with a square root of 2. Don't reduce that square root of 2 because this is connected as one unit, and we want to reduce that factor by 2 and not the actual square root portion. So our final answer, one answer is 2 plus 2 square root of 2, and the other is 2 minus 2 square root of 2. And that is the quadratic formula for when you have three different terms